Alright, let's dive into something mind-blowing. Imagine staring at the sun, not just a blurry orange disk, but its surface in unprecedented detail. I'm talking about the highest resolution image ever captured of our star, and it's revealing things we've never seen before. This isn't just a pretty picture, it's a game changer for understanding how the sun works. So, what's the big deal? Let me break it down for you. First, let's talk about how this image was taken. The Daniel K. Inouye Solar Telescope in Hawaii is the hero here. This isn't your average telescope, it's designed specifically to handle the sun's insane brightness and heat. Personally, I think it's wild that we've built something capable of resolving details as small as 20 kilometers on the sun's surface. To put that in perspective, it's like spotting a coin from 180 kilometers away. That level of precision is nuts, and it's opening up a whole new world of solar science. Now, what's in the image? The sun's surface, or photosphere, looks like a chaotic dance of plasma. You've got these band-like and vortex-like structures, almost like whirlpools in a cosmic ocean. What makes this really interesting is that these patterns are linked to something called Kelvin-Helmholtz instabilities. If you're not a physics nerd, don't worry, I'll explain. This is a phenomenon where two fluids moving at different speeds create ripples and vortices at their boundary. Think of wind blowing over water, creating waves. But here, it's happening on the sun's surface, and it's a big deal. In my opinion, the most fascinating part is what these vortices might tell us about the sun's mysteries. For years, scientists have been scratching their heads over why the sun's outer atmosphere, the corona, is millions of degrees hotter than its surface. These plasma whirlpools could be a piece of the puzzle. They're essentially stirring up energy, possibly transferring heat and magnetic energy across the sun's surface. If you take a step back and think about it, this tiny process, happening on a scale we can barely resolve, could be driving the sun's massive energy output. It's like discovering that a single gear in a clock is responsible for keeping the whole thing ticking. What many people don't realize is that this isn't just about the sun. Understanding these processes could help us predict solar flares and space weather, which can mess with our satellites and power grids. From my perspective, this image is a reminder of how much we still have to learn about our own star. We've been studying the sun for centuries, yet it's still full of surprises. One thing that immediately stands out is how these vortices are tied to magnetic fields. The sun's magnetic activity is what drives everything from sunspots to solar flares, and these tiny whirlpools might be where it all begins. A detail I find fascinating is how these structures sit at the edges of granules, these cell-like patterns that cover the sun's surface. Granules are basically convection cells, where hot plasma rises and cooler plasma sinks. But these vortices are like the fringes of that process, where things get chaotic. What this really suggests is that the sun's surface is far more dynamic than we thought. It's not just a static ball of gas, it's a living, breathing system where every little movement matters. This raises a deeper question: how much more is there to discover? We've only just scratched the surface, literally. If these tiny vortices are so significant, what else are we missing? Personally, I think this is just the beginning. With better telescopes and more data, we might uncover even more about how the sun works, and by extension, how stars across the universe operate. So, here's my closing thought: the sun is our closest star, yet it's still full of secrets. This image isn't just a scientific achievement, it's a reminder of how small we are in the grand scheme of things. And yet, it's also a testament to human curiosity and ingenuity. We built a telescope that can see the unseeable, and in doing so, we're rewriting what we know about our star. What do you think? Does this make you see the sun in a whole new light? Let me know in the comments, I'd love to hear your thoughts.